Alaikum wa rahmatullahi wa barakatuh. Today we will be looking at motors and generators. Now if you look at a motor is something that turns, and in order for a motor to turn we need electricity. We need electricity to turn the motor, so we need electricity. And we see that inside the motor, when we will look at it a little later, we need a magnet. And when the magnet and the electricity work at 90 degrees to each other, we'll see that we create movement of the wires inside the motor. Now, in order to work out which way the motor is going to turn, we need Fleming's left-hand motor rule. Now, if you look at this picture that we have here, the Fleming's left-hand motor rule, we see that the first thing we look at is the field. The forefinger, the pointing finger that we have is the field. It shows the direction of the magnetic field. Then what we will look at, the second aspect to look at is which way is the current flowing. And thereafter we will decide which way the motor is going to turn. So if you look at the motor, basically we use motors in our kitchen where we have to switch on your appliance. So you need electricity, and the magnet inside the motor causes the rotation of the blades of the Magimix or the appliance that you have. So we need electricity. So in order to identify a motor, we must have an electric current and we need a magnet. Now going further, if you look at this next slide, we see as an example of a motor. This motor is turning, and according to what they say that the motor rotates clockwise. Now let's use Fleming's left-hand rule and see if this is correct. If you look at this motor, the parts of the motor are important. Before we even look at Fleming's left-hand rule, we see that we have a coil. The coil is where you have these wires. Thousands of times the wire is wound around a metal, soft metal core, and we see that creates the coil. Sometimes they don't use the word coil, they'll use the word loop, or they may even use the word windings. So those are windings. So those are the terminology that they use for this wire that is going inside a magnetic field. Then we have the magnet, the north to the south to the magnet, and then here we have the commutator, which reverses current for every half a turn. And then we've got brushes here. The brushes are the contact points that allow the wires to be in contact with the loop, because if the loop was fixed to the wires, then the wire will get tangled. But because it is just in contact, it is just touching, you need brushes so that you can allow rotation of the coil. So if you look at this motor, we see here's our magnet, our battery. So our current goes this way. We'll just follow our current. Our current goes through this way, and it goes up. We've got an arrow there. The loop is here, and the current comes down, and the current goes back to the battery. Now, if we want to figure out which way this motor is going to turn, what you use is Fleming's left-hand motor rule. So here we've got a picture. So the first thing you identify is your magnet. Your magnet is from north to south. So here's Fleming's left-hand motor rule. You have to place your three fingers at 90 degrees to each other. So we see that the field is first. It's from north to south. So it's going north to south. Then we say our current in this case is coming towards you. So if you look at this, let me stir it a little bit. It's coming towards you. So the current comes towards you. So using your left hand, the field, you always work with the field first, north to south. Current is coming towards you. You have to choose one side. So we have chosen this side of the motor, this side. So the current is coming down. So your north to south is left to right. Here's your field, left to right. The current is coming towards you. And we see that as a result, the thumb is pointing up. So that means this whole wire will be pushed upwards. And if you look on the right hand side here, we'll see that here's this wire is being pushed upwards. It's going like that. It's being pushed upwards. So if the top part of the wire is pushed upwards and the bottom part of the wire is pushed downwards, then we see that the loop will rotate in this direction. And if you look at the clock, then this direction will be a clockwise direction. So this is an example of how you work out which way that the rotation of the motor is turning. Is it clockwise or anti-clockwise? And in this case we see, because this side goes up, this side will go down, and then we get a clockwise rotation of this coil. So that's a very important point to remember. Right, going further, if you look at this example, we see that firstly we have to identify if it's a motor or a dynamo. And here we see that we've got a cell. So because there's a battery, or what we call a cell, we can say that this is a motor. So you're supplying the current to the circuit. Let's just see which direction is this circuit being supplied. So the current is going down this way. Here you've got your commutator, splittering commutator, splittering commutator, and here we see that there's a loop of wire here. And if we have to start this example, we see that it is rotating in this direction, and if you have to look at it from the front, then that will be an anti-clockwise direction, Now if we look also here at this motor, we see that when the motor is in line, when the wire is closest to the north and the south pole, then if you look at this graph, we see we get peak EMF, peak voltage that is formed. And when the loop is perpendicular or furthest away from the north and south pole, then we see that our current is minimum. So we get maximum when the loop is in this direction, and we get minimum when it is away from there. Now in the textbooks generally we see that what will happen is that they have north here and they'll have south there, and what will happen is if your loop is like this, then we'll have maximum. That's this point here. But if you have a case where the magnet has the north and the south in this direction, then you'll have minimum. Now, just to explain this a little further, if you look at this wire, the current is moving towards you in one direction and away from you in the other direction. So you have to see it from the front view. You will see it like this. On the one side there will be a dot, and the one side will be a cross. The dot means current coming towards you, and the cross means current going away from you. So that is the Fleming's left-hand motor rule. Before we go to this example, I just want to show you another demonstration of the Fleming's left-hand motor rule. If we take this motor as an example, we see that here is a motor. Again, you have your north pole, and this is the south pole of the magnet. So the magnet is working downwards. Here we have our split ring commutator, and every half a turn you'll see the color changes because the split ring commutator alternates the current, and we see that we get the loop having a force that's pushing it in one direction towards the left. If you take the top part to the left, and then the moment it goes past the commutator, we see that it is pushing it to the right. So that allows continuous rotation of the coil. That's a very important aspect as well. Okay, so what we will do now, we will stop there, and we see that this is the example of how basically how a motor works. Thanks for your time.